You click a slicer and nothing happens. Then a spinner, then about 8 seconds later, the numbers finally arrive. And by then your stakeholder has stopped looking at the screen. Or worse, you're in a meeting, someone asks, "Can we see just the south region?" And you have to say, "Yeah, give it a moment." That's the thing I want to fix today. And I want to be direct with you about the cause, because there's a lot of bad advice about this. It is almost never your laptop. It is almost never the amount of data. And it's almost never something you fix by removing visuals or buying more RAM. In the vast majority of slow reports I've seen, it comes down to one structural decision made right at the beginning, usually by someone who didn't know it was a decision. You built one big flat table. And I want to be fair here, because that choice feels completely reasonable. You had data in a few places, you merged it all together so everything you need is in one place, and it worked. It worked at 10,000 rows, it worked at 100,000. And then somewhere around 1 million, it fell off a cliff. And nothing you do to the visuals brings it back. So today, why that happens, what to build instead, and how to actually diagnose it rather than guessing. And one thing I'll say upfront, nothing today requires you to buy anything or to be an expert. The fix is a shape, and once you can see the shape, you can't unsee it.
First, let's be precise about what slow actually means, because there are different kinds and they point at different problems. Kind 1. The report takes 15 seconds to open, but once it's open, clicking around is fine. That's usually a load problem. Too many visuals firing at once or a huge model being read into memory. Kind 2. It opens fine, but every single click takes several seconds. That's a query problem, and that's the one we are talking about today. That's your model. Kind 3. It's fast for you and slow for everyone else. That's usually a capacity or a gateway problem, not your model at all. So diagnose which one you have before you start fixing things. Now, the wrong fixes. I see these constantly. Deleting visuals. That helps a bit, and it treats a symptom. Turning on direct query because someone said it's faster. It is almost always slower, and now you've moved your problem onto a database. Buying a bigger capacity? That works, in the sense that throwing money at anything works, and your model is still wrong. And rewriting your DAX to be cleverer, which is genuinely satisfying. And if the model is bad, you're optimizing a formula that shouldn't have to work that hard in the first place. One more diagnostic that costs you nothing. Open the report on a colleague's machine. If it's slow there too, it's the model or the capacity. If it's only slow for you, it's your laptop or your network, and you've just saved yourself a day of pointless optimizing.
So let me describe the mistake properly. The flat table. You've got orders. Each order has a product, and that product has a name, a category, a subcategory, a supplier, and a unit cost. It has a customer, and that customer has a name, a city, a state, a segment, and a sign-up date. And rather than keep those separate, you join it all together in Power Query, and you end up with one beautiful white table where every row has everything on it. 60 columns, 2 million rows. And it feels great because you can drag any field into any chart and it just works. No relationships to think about, no model view to understand. Here's what you've actually built. The product name Aurora Laptop 14 is now written into your model 200,000 times because that product was sold 200,000 times. The customer's city is repeated on every order they ever placed. The supplier name, the category, the segment, all of it duplicated across millions of rows. And crucially, every one of those repeated values is text, long, human-readable text. Now the engine does compress this, and it's cleverer than people give it credit for. But to understand why it still hurts, you need about 90 seconds on how the engine actually stores your data, and it's genuinely interesting. And there's a second cost that shows up later. When a product gets renamed, you have to fix it in 200,000 rows instead of one. Flat tables aren't only slow, they're fragile.
Power BI does not store your data as rows. It stores it as columns, and that one fact explains almost everything. It's called VertiPaq, and it's an in-memory columnar engine. So instead of keeping row 1, then row 2, then row 3, it keeps the entire product column together, then the entire city column together. Why does that matter? Because a single column contains values of the same kind, and values of the same kind repeat, and repetition compresses beautifully. The main trick is called dictionary encoding. The engine looks at your product column, finds every distinct value, and builds a small lookup table. Aurora Laptop is 0, Nimbus Buds is 1, Vertex Monitor is 2. Then it replaces the actual column with just those numbers. So 200,000 copies of a long product name become 200,000 copies of the number 0, which is tiny and which then compresses again. And this is where the important idea comes in. The thing that decides how well a column compresses is not how many rows you have. It's how many distinct values are in it. That's called cardinality, and it is the single most important word in this video. Low cardinality compresses to almost nothing. High cardinality barely compresses at all. There's a related trick called run length encoding. If a value repeats consecutively, the engine stores it once with a count, which is why sorting your source by a low cardinality column can genuinely shrink your model. Watch what that looks like.
So now the fix, and it has a name that sounds more intimidating than it is. The star schema. The idea is that your tables come in exactly two flavors. Fact tables hold events, things that happened. One row per order line, per payment, per website visit. They're long and narrow. They contain numbers you'll add up and short codes pointing at other tables. And they grow forever. Dimension tables hold descriptions, things that exist. One row per product, one row per customer, one row per date. They're short and wide. They contain the attributes you filter and group by, and they barely change. Draw it out and it looks like a star. The fact table sits in the middle and the dimension tables sit around the outside, each connected by a single relationship. Hence the name. So instead of one table with 60 columns and 2 million rows, you have a fact table with maybe 8 columns and 2 million rows, and 5 little dimension tables with a few thousand rows each. And the total size of that is dramatically smaller. Not 10% smaller, often 5 or 10 times smaller. And here's the thing that surprises people. It's not smaller because you deleted data. All the information is still there. It's smaller because of how it now compresses. And there's a bonus unrelated to speed. DAX gets easier. Filters flow from dimension to fact, which is exactly what Calculate was designed around. Most confusing DAX comes from a model that isn't this shape. Let me make that concrete, because this is the whole argument. In your flat table, the product name column has 2 million rows and say 400 distinct values. That compresses reasonably, but the column is still 2 million entries long and it sits inside a table the engine has to scan. In the star, that product name exists in exactly 400 rows in a tiny dimension table. And in the fact table, all that's left is a product key, an integer. Integers are the best case for this engine. They compress harder than anything else and they compare faster. So 3 things get better at once. 1, your model gets much smaller, so more of it fits in cache. 2, when someone filters by category, the engine scans a 400-row table to work out which products match and then applies that to the fact table using integers. In the flat table, it was scanning 2 million rows of text every time. 3, and this is the one nobody mentions. The engine was designed for this shape. VertiPaq and the DAX formula engine assume a star. When you give it one, it takes the fast path it was built for. When you give it a flat table, it still works. It just never gets to use the optimization it was designed around. One number to hold on to. Going from flat to star typically cuts file size by 3 to 10 times. That's not a tuning gain. It's a different category of result, and you get it without deleting anything. Watch the same report on both. Okay, practical. How do you actually get from a flat table to a star when you already have the flat one? You do it in Power Query, and the process is genuinely mechanical. Take your flat table, reference it. Don't duplicate it, reference it, so you're not reloading the source. From that reference, keep only the product columns. Product code, name, category, subcategory. Then remove duplicates. You now have a product dimension. Repeat for customers and for anything else that describes rather than measures. Then go back to your original query and remove all the descriptive columns, keeping only the keys and the numbers. That's your fact table. Load them all, go to model view and drag the key from each dimension onto the matching key in the fact table. One to many, single direction,
every time. And then two things that matter enormously. First, build a proper date table. Do not rely on the date column in your fact table. And second, go into options and turn off auto date time. That setting quietly creates a hidden date table for every single date column in your model. And on a model with 6 date columns, it can be a genuinely significant chunk of your file size doing nothing useful. One more setting while you're in there. In the model view, select each dimension key column and set summarization to none. Otherwise, Power BI will happily let someone drag a customer ID into a chart and sum it, which produces a number that is meaningless and looks perfectly legitimate.
Now let me be honest with you, because if I told you the model was the only cause, I'd be selling you something. Here are the other things that make reports slow, roughly in the order I check them. 1. Too many visuals on a page. Every visual is a separate query. 20 visuals means 20 queries every time someone clicks. 6 good visuals genuinely beat 20 mediocre ones for reasons that have nothing to do with design. 2. Bidirectional relationships. Somebody switched one on to solve a problem, and now the engine has to consider filter paths in both directions on every query. 3. Calculated columns doing work that belongs in Power Query. A calculated column is computed and stored for every row. If it can be done at load time, do it there. 4. Distinct count on a high cardinality column. It's genuinely expensive because the engine has to hold every unique value to count them. 5. Complex measures using filter over a large table when a simple condition would do. And 6. Direct query when you didn't need real-time data. Most business reporting does not. Nobody makes a different decision because a number is 4 hours old. And a 7th that's easy to miss. Loading columns you never use. Every extra column costs memory even if no visual touches it. Go into Power Query and remove them at the source. It's the cheapest optimization available and almost nobody does it. So how do you find out which of these is actually your problem instead of guessing? 3 tools, and the first one is free and built-in. Performance Analyzer on the View ribbon. Turn it on, click Start Recording, then interact with your report. It shows you every visual and exactly how many milliseconds each one took, split into DAX query time, visual display time, and other. That immediately tells you whether it's one guilty visual or everything being slightly slow, and those are completely different problems. Second, DAX Studio. It's free, it connects to your open Power BI file, and it lets you run queries directly and see server timings. That's how you tell whether time is going in the storage engine, which usually means a model problem, or the formula engine, which usually means a DAX problem. Third, and this is the one I'd point you at for today's topic, VertiPaq Analyzer, which is built into DAX Studio. It shows you the size of every single column in your model sorted. And that list is often shocking. People find one text column taking up 40% of their model. And a rough rule for reading that list. If a single column is more than about 10% of your model, ask what it's for. 9 times out of 10, it's a high cardinality text column. Something like a transaction ID or a free text comment that no visual actually uses. Let me show you what that looks like. So let's pull it together. If clicking a slicer is slow, it's a query problem, and that usually means your model. The mistake is one big flat table, which repeats long text values across millions of rows and never lets the engine take the fast path it was built for. The fix is a star schema, a narrow fact table of keys and numbers in the middle, small dimension tables around the outside, one-to-many, single direction, plus a real date table and auto date time turned off. And before you touch anything, measure. Performance Analyzer first, then VertiPaq Analyzer to see where the size actually is. Now one honest caveat, because I don't want you rebuilding things unnecessarily. If your model is under a few 100,000 rows, none of this will be dramatic. It'll still be better practice and it'll still make your DAX easier to write, but you will not feel a speed difference. And that's fine. This matters at scale, and it matters most when the report is going in front of people who are impatient. The reason I'd still learn it now is that the shape of your model is the hardest thing to change later. Everything gets built on top of it. And if you take one word away today, make it cardinality. How many distinct values a column has decides how it compresses, which decides your model size, which decides how fast it feels. Tell me in the comments how big your slowest model is. Subscribe if this helped. See you in the next one.